So in this video, we'll be talking about the kinematics equations, and these are basically the equations you'll need to know to solve problems involving velocity, acceleration, time, distance, all that type of stuff. Now, here are the four that you'll need to know. For the AP, they say there's 5, but really the 5th one is a variation on this second one here. So you don't need to worry too much about that. And they give this to you on that big formula sheet. So these will all be available to you. So you don't need to memorize them, but you do need to know how to use them. And the first thing you want to note is that these only work. So these only work when acceleration is constant. So that just means like acceleration is one fixed value and it doesn't change off of that. All right, so let's also note that in each of these big four, I'm going to call them, in order to know which one to use, you need to figure out which variable is missing. So the big things you need to know are what is the initial, what is the position, or yeah, we can say x or d for displacement slash position, or change in position actually. And then we also need to know acceleration. We also need to know velocity initial, which is v naught, velocity final, which is just v or v final. And we also need to know t. So these 5 things are the things that you need to know to solve anything, right? So the problem is, in certain problems, they're not going to give you all of these values. So you need to figure it out. So like, let's say we need to find acceleration, but we're only given the initial velocity, the ending velocity, and the time. So in that case, you would want to use number 1 because we don't know what d is. So this is the only equation that doesn't have distance in it. So we'd have to use number 1. So just to write it down, what are we missing? Note for number 1, in the first one, we are missing displacement. For number 2, we're missing the final velocity. For number 3, we are missing, time. And for number 4, we're missing acceleration. So if you know what you're missing, you know which one to not use. And basically, you'll just need to identify. So my recommendation is just to write down everything you know so you're able to figure out which one to use. So with that in mind, let's get to doing some problems. All right, so the first question is, a ball is dropped from rest and takes 3 seconds to reach the ground. How far did it fall? So my first step would always be to draw something. So we know that this is the direction of the ball drop. It took 3 seconds. So t, we'll write that down, is equal to 3 seconds. And what else do we know? We also know that a is equal to negative 9.8, right? But I'll actually round this to 10 just to make it easier. It's not too difficult. 10 meters per second squared. So is this enough to know how far it fell? Well, actually, it is. So we know we have t and we have a. So which of these kinematics equations should we use if we want to know how far it is? Well, conveniently, we have d is equal to 1/2 a t squared plus v0t, right? But it tells us it falls from rest. So the last variable that we actually know is v0 is 0 meters per second. And that conveniently cancels this part out. So we have d ends up being 1/2 over 10 times 3 seconds squared. And this becomes 5 times 9, which is equal to 45 meters. And that is our answer. All right, and then for this next question, we have a car accelerates over a distance of 10 meters, so d equals 10 meters, starting at 1 meters per second, so v0 is equal to 1 meters per second, and ending at 10, so v is equal to 10 meters per second. What was its acceleration? Okay, so we know this, and we want to know these four. So the one we're missing is time. So the kinematics equation we would use for this is v squared is equal to v initial squared plus 2ad. So just plugging some stuff in, we get 100 is equal to 1 plus 2a times the distance, which was 10. So it's like this. So we get 99 equals 20a. A is equal to 99 over 20 meters per second squared. All right. And we'll do one last problem. So for our last question, we have a cart is traveling at 5 meters per second when it starts accelerating at 2 meters per second squared for 3 seconds. How far does it travel in this time? Well, to start, we know that its v initial is equal to 5 meters per second. Its acceleration is equal to 2 meters per second. And it does this for a time of 3 seconds. So we're missing its distance. And we don't have final velocity. So for this one, we will use d is equal to 1/2 at squared plus v0t, because this one does not require our final velocity. So just plugging some values in, we're going to get d is equal to 1/2 times 2 times 9 plus 5 times 3, which is 15. And this will give 9 plus 15 is equal to 24 meters. All right, so that's all I have for today, and I'll see you guys next time, where we'll be going over projectile motion.